All right, let me get started over here. We're going to talk about real-time rollups and Bitcoin security. Can we have both? All right, I'm the founder of Stargaze. Stargaze is an app chain for NFTs and more. It's the home of bad kids and Celestine sloths. Anyone here have a bad kid or a sloth? All right, now lick your elbow. No one's licking their elbow. What? Okay, anyway, in a previous life, I worked on low latency audio engines for iPhone apps. And before that, I worked on scaling Web 2 apps at Groupon. And there's a bit more, but I'm going to continue with my talk. So we're going to talk about building real-time rollups without sacrificing the values of crypto. And I'm going to define real-time here as a Web3 query or a Web3 transaction being as fast as a Web2 API call. Just a little bit of context. The thesis for Stargaze has been that NFTs are a stepping stone to bring in more users into crypto, and we want to build the best possible UX because right now we're a product for kind of crypto natives, but also at some point we want to bring in more mainstream users. We've always kind of operated as a kind of more of like a bottom-up way as opposed to like a top-down fashion. We kind of start out building the apps, and then we scale infra as needed. This is kind of more how it works in traditional startups in Web 2. You can achieve product market fit. You can iterate quickly. You can get feedback from the users. I'm not saying there's one right way to do things, but the downside of this approach is we can't start with the end game first. We have to re-engineer and modify things. It's like updating a plane while it's in the middle of flight. Of course, I won't be here if I didn't believe in scaling the modular way. Instead of just scaling a single CPU or like, if you think of if you think of a blockchain as like a computer, right? You can think of RAM as like data availability. You can think of GPU as like execution, CPU as consensus, right? You just don't scale one of them. You break them out into components and you scale each one. So why focus on performance and speed and UX, right? If you look at history, speed was really important in terms of certain products like winning in their class, right? I remember when the search engine wars happened in like Web 1, Google won partly because it was just really fast. It was able to produce the results in like half a second. Alta Vista and Yahoo and others, took 2 to 10 seconds or so. If you think about Uber internally, they're obsessed with the time to find a car, and they trained this transformer model called deep ETA with graph theory to be able to optimize the process of finding a car. There's so many other examples of this, like Amazon with their one-day shipping and so forth, right? And if you kind of apply this to blockchains, if you have a blockchain that has really good UX and is super fast, it attracts all these users, and then that will attract more TVL, that will attract more volume, and then that brings in more users, right? And then you can learn from them, and you can further optimize the speed and performance, and that brings in more TVL and volume. So it has this positive feedback loop. So where do users spend most of their time? They actually spend most of their time querying data on the blockchain. They're not spending most of their time submitting transactions to the blockchain, right? They are finding yield opportunities. They are browsing around for NFTs, trying to find a slot that looks like them or whatever, right? So we spend a lot of time optimizing reads. So we built this indexer called Constellations, which is built in Rust, is super fast, is async and multi-threaded. It can index a Cosmos chain like Osmosis or something in under 5 hours from Genesis. And this is kind of like the secret sauce that makes the website really fast. We also have a geo-distributed RPC cluster and we have read optimized RPCs. So like most of the Merkle tree is cached in RAM. It makes reads super fast. And we're working on like a new version of this that puts the entire Merkle tree in RAM. So after you've optimized reads, you want to focus on optimizing writes. So there's two ways to do this. You can scale the L1, which is kind of like the Solana approach, right? Or you can build rollups and layer 2s. So in terms of scaling the layer 1, there's also some like lots of good research in this area in scaling Tendermint, BFT. Dev from Osmosis gave a talk a few weeks ago at DevMos about how he thinks we can bring Tendermint down to like a second or two, which is going to be awesome. And then obviously the other approach is rollups, where you decouple consensus and execution. I really like this approach because you have a separation of concerns, right? You do one thing and do that one thing really well. And then you reduce the latency down to the speed of execution. And the other thing is it opens the door to fractal scaling, right? So you can have L3s and so forth, blockchains on top of blockchains. Another thing that I really like about it is that as an app developer, you don't have to leak MEV to the base layer, right? On Ethereum right now, there's a lot of talk on base rollups because people don't want to leak MEV or keep MEV at the L2 layer. But I would argue as an app developer, if MEV is the largest source of revenue in crypto, then you should kind of own that, right? So Rollkit and Celestia are great technologies to build rollups with. I like Rollkit a lot because for execution, it's just Cosmos SDK. So you can have CosmWasm, you can have EVM, you can have custom modules. Instead of Tendermint, it doesn't have Tendermint, right? So it's super fast. There's no rounds of BFT. And also it uses libp2p, which is this modular networking stack built by Protocol Labs, and it's less buggy and faster than Tendermint's custom P2P. And of course, Celestia, data availability sampling, kind of best in class. You can have this super light nodes, and the more light nodes that are running, the bigger kind of block sizes that you have, and that's all great. The other thing you get with rollups is fast pre-confs, right? So because if you're running something like CosmWasm, the native execution speed is super fast, like in the order of like a few milliseconds, maybe like 1 through 5 or something, right? So your pre-conf speed is like pretty much just the latency of one global ping. So so now the user can like click on a transaction and do something in like 100 milliseconds, which is incredibly fast, right? Okay, so I know what you guys are thinking. This is a centralized sequencer. Like, how can we make it like not centralized and stuff like that? Well, one thing I like is Babylon Bitcoin staking. So this is not live yet, but this is still in development. But the way this works is that the sequencer signs a transaction and stakes some Bitcoin on the Bitcoin side on the layer 1 of Bitcoin. And then it signs this extra transaction on the when it signs sequencer transactions. And then when if it double spends, it leaks that private key. And then when it leaks that private key, anyone can kind of take it and then slash the sequencer on the Bitcoin side. So this is really good. It prevents forking attacks on the sequencer side. And then another reason why I like it is that this is staking. This is not restaking, right? So it doesn't have like additional level of hypothecation. And then, of course, Bitcoin is the most credibly neutral network, most dominant currency, just lots of capital sitting around and people wanting to earn yield on it. All right, going to go into shill mode a little bit now. Gonna use all this and build. We're working on Stargaze L2 called Astra. Astra is going to be a CosmWasm layer 2. Is going to run at near native speeds. Is also going to have native yield. So we're working with Stride, Noble, and some others on native yield on it. And it's going to be running Skip's block SDK, which will enable developers to share MEV with Stargaze L1 as well. Why are we doing this? So Stargaze is kind of at a point where like Amazon was when it was only selling books. We have users that are asking for a bunch of other things. There's already something like 40-some apps on Stargaze, but we want to kind of open it up, make a permissionless environment for people to come and build new apps. And what I'm most excited about, though, is this kind of real-time rollups enable like a new class of apps, right? When everything's as fast as a normal web app, I'm really looking forward to like new kind of 0 to 1 apps, like maybe games and social media and stuff like that. So we're going to have native yield with Stride assets. Also for stables, we're working with Noble on that. And also there's a new class of like Bitcoin restaking kind of protocols that are out there that we're going to use for Bitcoin yield. So I'm going to talk about how the native yield works with Stride, and thanks for the Stride guys for this awesome diagram here. The way it works is that, let's say you're on Stargaze L1 and you want to send some stars to Astra. When you do the transaction, what actually happens behind the scenes is that those stars get liquid staked on the Stride side. Then it goes through a hyperlane yield route, and then it gets locked into a vault. So the staked version of the asset is in this vault. And then it talks to a rebasing contract that every epoch will mint more of the asset, more of like stars, for example. And now these tokens can flow into user accounts, and they can also flow into contracts, right? So this kind of opens the door to building like new different DeFi apps, because you're having yield flow into your contracts, right? So some of that yield could maybe go as like, it could be protocol revenue, it could be some kind of reward to the user. There's like all kinds of things you can do with this. Another thing that Astra is going to have is not going to have a dispute period. If you use Base or Optimism and so forth, there's like, I think like a 2-week window if you want to withdraw funds. You can go through like some other bridge, but you have to like pay a fee for that. But there's this technique called pessimistic validation, and this is by Yermoon. He actually gave a talk on this, so if you want to learn more about this, go and watch that talk. But at a high level, the way this works is that the validators for Stargaze L1 will run full nodes of Astra, and then they're able to get the current state of the rollup, and they can update the IBC Lite client that's running on Stargaze L1. So they're kind of like validating the IBC connection between the rollup. So now you can just do regular IBC between the rollup and Stargaze L1. And you don't have a dispute period, right? So this is super nice. But this also opens the door to like do like IBC routing. So let's say there's another L2 on Stargaze, right? Now you can have like atomic cross-chain composability, because you can send IBC messages across the rollups, and without having any kind of delay or dispute period. All you had to deal with is the 3 blocks or so for the IBC transaction to happen. And of course, the end game is ZK, right? The end game is to ZK prove execution and consensus. But it's not at the level. It's not fast enough for what we need yet. But that's going to be the end game of this stuff. All right, show mode off. All right, so just to recap here, real-time rollups can give you awesome UX, opens the door to new 0 to 1 apps. It creates this user adoption feedback loop. And then native yield will give more optionality to devs. You have yield flowing into your contracts. And then finally, you can secure the rollup with Bitcoin staking. So I think this solves a lot of problems and kind of creates something new, a new opportunity for devs to build on. All right, well, that's it, folks. You can follow me or Astar Stargaze on Twitter. And that's it.